All right, so I don't want to take too much time, but I want to introduce our next speaker. So our next speaker is Dmitry Petrov. He is the creator of DVC, which I am a huge fan of. Because anybody ever run into issues versioning their data? We're all used to versioning code, but is anybody running? All right. This is your guy for that type of stuff, and as you would talk about even some of the harder challenges than like the trivial challenges that I've raised. So, really excited to have you. There you go.
Very happy to be here. So I took a night flight today from San Francisco. So red eye flight, and even like my t-shirt is red, so too much the color. Pardon? Neither. So today we'll be talking about versioning multimodal data, and specifically metadata, the role of metadata and how to use metadata in this process. I work with data for like all my career. My PhD is about data. I was working for almost 5 years at Microsoft, when I spent tons of time for data feature engineering, data cleaning, like everything that you need to build models, right? As you remember, this like old job that you spend 80% of your time to prepare data, right? And only like 20 model. That's, of course, like was the case at the big company. And I believe today we are also like moving to this world when progress of AI models will kind of stabilize at some point, and we'll be spending more and more time on prepared data. And we are seeing this patterns already in some companies. So also I built the open source tool DVC, which we mentioned before briefly. It's a data version control. Anyone heard about DVC? Oh, cool. Thank you. And now I'm working on a new project, a new company, which is called Data Chain. It's about multimodal data. It's about data infrastructure with a specific. So yeah, right now to focus on data chain, multimodal data. It's about versioning not only data but metadata. And I believe the metadata become like the most important part of the data curation process with a in multimodality. Let's try this. Yeah. So today there are like 3 blocks in the presentation. First block is kind of like more theoretical about metadata and why we need this. Why metadata is the key to be like efficient. In order to process images, videos, audio, etc. We will talk about some challenges at how we can overcome the challenges with Python and specifically Pydantic. Anyone heard about Pydantic? I believe everyone, because like every LLM use Pydantic these days. Almost, I think. Yeah. And we will talk about data aberrations, like how to share data set, div data set, and this kind of traditional challenges, I would say. Okay. So metadata. When we start working with on DVC like 7-ish years ago, we were focusing mostly on data, like data artifact, data sets. But today, with the multimodal data set is clearly not enough. There is a big paradigm shift happening these days. If you experience enough, you probably know the term big data. When I moved to US like around like 14 years ago, like it was all about big data. Everyone was talking about this. Like it's just like a structured data sets, right? It's kind of like Excel spreadsheet with all the columns, types, and data, right? But usually like big scale, like millions and billions of records. That's what I did at Microsoft on clickstream and NLP, like analyzing like a search, performance of search engine and building model for them. But today with Gen AI, we have this opportunity to not analyze just a structured data when it's pretty clear how to analyze it, right? But also we can analyze not structured data, which is our images, audio files, PDF files, and such. And this requires like a little bit different approach of dealing with the data. today we are not talking about big data. We are talking about heavy data, what you like to call heavy data, which means the files are usually pretty large. We're talking about megabytes, sometimes gigabytes, right? Like a one single file, one single data point. But actual information that you need from the file, it's relatively small, right? Sometimes just one bit of information, like if there are any people on 5 hours of video recording, great. Sometimes a bit more. But the patterns definitely change. We are not kind of focusing today. We're mostly focusing today on how to efficiently like move the data to the GPU, to the LLMs, or your local machine, rather than processing in a large scale. However, amount of data is usually also big, right? Thousands, millions, in some cases even like billions of files need to be processed. And this is like the files are heavy. That's why one of these why metadata becomes the core part here. You need to know you need to have not just a file, but like you need to understand what is inside the file. And this information usually like people put to some JSON next to the file or some Parquet file next to it, right? Because you don't want to run LLM every time you need to like see like what is inside. This is like how it can look like. So you might have like S3 or Google Cloud. There are some images, right? And each image has JSON or maybe TXT or both. Like in this case, it's a line data set. And this JSON like explains like what is inside. This format and this approach pretty much any team start with, but usually the team run into some challenges, and most of the challenges related to the performance and efficiency, because you don't want to like manage like millions of like these like tiny small files. You want to have a kind of like a more systematic like faster approach of working with this. And of course, like teams quickly become caching data, like just giving all the files, meta files first, and I will be like analyzing them. Then some teams end up having like a database, and based on like what I see, the most efficient team, they use databases, like centralized databases for all the meta information. It just makes them like way more efficient when you can just query across like a millions of files, like filter down subset of files based on some parameters. It just helps teams become more efficient. This is how it can look like. You need to keep like a references to the files, right? Like a file name, path, bucket, some e tag for consistency, right? And then you put meta information next to the file, right? In this case, a little bit complicated structure with the binding boxes. But you got the idea, right? And like a lot of teams like have implemented this approach and use this approach very efficiently. So easy to filter. You can handle crazy scale. Like some teams working with like billions of files, right? And once you like can put this in a database, or maybe like data warehouse, like why not? Easy to modify. That's a great foundation for file versioning, diffing, and etc. Because it basically comes down to manipulation of this like a data sets. The tables in the database. And when we have seen this pattern like over and over and over and over again, we decided like why don't we come up with some approach that's kind of like mastering this patterns, but mastering this the tool that people customly built over and over again, right? We clearly need to be very focused on files and storages, because this is like the biggest bottleneck of this like a heavy data world. And new Gen AI approaches working with the data. We need to handle like a large scale. Some teams, as I said, work on big on scale, or even like 10,000, 100,000 is already like something that you need to. It's better to optimize. Parallel processing. Downloading data in parallel, uses like async download and etc. That's of course like must have in this world. And the one tricky part here is people put data in language that people use. Because in many cases, when people put database in their team, it's kind of like creates like a border between people who like SQL and who don't like SQL. And also it creates like some like islands of codes, because a lot of people want to avoid SQL as much as possible who don't like it, right? So in middle world, we need to kind of like a way to work with these databases through Python in some way. So let me show you how what we come up with in Datashin to give you some idea. One sec. So I hope internet works and everything is great, because I don't have plan B today. I never do, but first of all, we should be able to just look up at the files, right? Okay, what we have in this storage, in this directory, right? So that's the list of the files. File size. That's actually everything. There's a lot more information there. It's e-tag, version, like everything that bucket contains is in the table, but by default we got only two basic signals, right? And then we need to like analyze the files and evaluate if the text, the dialogues from these files was successful or not. We will be using LLMs, Mistral with a very naive prompt. In reality, it will be like a lot bigger, of course. But it gives you like some ideas. What we want to do, we want to get this data, right? All the files, and apply this logic and save this data set, right? Let's run it right now. So, in the code, it's very simple. I ask for a file, I read the content, and then I do like whatever I want and return what I specified in the function, right? And it runs file by file and produces me, if it all looks good, it should give me like, for each file, it should specify the signal from LLM. Is it good dialogue, bad dialogue, according to the LLM. All right, so that's the result, right? The first file was successful, the 13 was successful, and so on and so on, right? You got the idea. But the idea is to kind of like manipulate with the files as you would manipulate with a data frame. And under the hood, there is a database that can handle like all the operations for this in a very efficient way. So that's how it can look like. So let's take this result chain. It's a previous variable, right? Let's filter successful files only. How many successful files we got? 32, right? If you don't like this kind of like a SQL-ish like Python code, you can just iterate through the objects and ask for all the objects, right? And output one by one the results, right? So files, if it's successful or not. So that's kind of like the very basic functionality. But the idea is to get the table, to build the table with the file references and meta information. So when we start working, so if you kind of like step one level, make one step back, you can see that this is like a way how we can reduce the problem of heavy data processing, right? The modern problem, the new problem, to the problem that we know how to solve, which is a big data problem. So we aggregate it, we get all the metadata, put to databases, put PyData on top, and then you can do like, you can apply the tools approach that you probably familiar with. So when we implemented this first time, it was like more than a year ago, probably even 2, and we start working with the teams using that approach. we very quickly run in some like a complicated challenges. I will go through these challenges very quickly. First challenge was the complicated data structure people need to deal with. I will start with the output, with the result, and then I will show you like how to get there. So in this example, people want to analyze images, and they need to run some model, like in this case YOLA, or maybe you can just throw image to ChatGPT, right, and ask binding boxes. You'll get the same result. The problem is the data structure is complicated in terms of like you might have multiple binding boxes for one single image, right? Person, two people here, right, in first image. In second image, I have five different objects, right? And if you go to the segment, to the paths, it's even more and more complicated, right? But it's really challenging to fit this complex data structure to the database, right? And solution that we come up with, let me do the same. Solution that we come up with based on the Pydantic library. Pydantic is a way to specify a Pythonic data structure, because ideally, like ideally you need to iterate with a Python object, and you need to say, okay, that's a Python object. I want to put Python object to database, right? But that's like not possible to do. I mean, you don't need binary in database. You need to kind of like clear columns. You need to efficient operations. You need to be able to work in a large scale, like millions of files and such. But with Pydantic, if your object, not just Python, but Pydantic, it's possible to extract the structure, clean, nice structure, and transpile the structure to the database structure. So this is like what data chain does. So in this example, we put this complicated binding boxes, segments, paths into another even bigger object, your data model, which is just Pydantic. And each of those are Pydantic. And then do the same thing here. Read all the data, set up some model, just technical details. I do limit just to make sure we have enough time, and apply this function. The function read data, each file is an image, right? And returns all the like these complicated objects that we already saw before, right? So you see this like a hierarchical multi-layer structure of this data frame, but all the information is presented. And now you can efficiently run queries, large-scale queries, like against database, right? Like how many people, how many images contain person or refrigerator, right? Or you can just iterate through the YOLO objects and do the same in a Pythonic way, if you kind of prefer Pythonic way, right? So it also helps you to understand what is inside the images. For example, like I don't want to download all the thousands and maybe millions of images. I wanna see images with refrigerator, right? So you run it. It downloads only a subset of images, and you see the images with refrigerator. Yeah, here it is. Here it is. So that's kind of like a way to deal with the complex data structure. And one example of a complex data structure is actually response from LLM. If you take a look at the response from Mistral or ChatGPT, all of those are Pydantic. They are complicated, a lot of signals, model version, time, temperature, and response is presented as a list of some another object with the content and blah blah blah. It's a complicated data structure, but you can just serialize this in a one line and put a database and query this object against database. So let's go quickly to the other types of iterations that people usually do with multimodal datasets. see. One of the common use case is to define data sets and what we call delta update, incremental updates. Example might be you want to compute embeddings for all the images you have in some bucket. But you might have like many of these images, right? Like maybe millions of these images. But that's all right. You invest time, you implement this, you do the compute, right? It might take like several days to do this computation, and then you added like 1,000 more images, right? And then 100 more images. But usually, like, it's not efficient to kind of do the update over and over again. You want to do incremental, like incremental small updates. So that's example like how it can be done here. First of all, we have done some computation for the embeddings before, right? It was the image and data set. So this is like some small sample of this. And let's take a look what changed in the bucket. How many images were added or modified from the bucket? So here you go, 6 images. And in order to do the update, proper update of the whole data set, you don't want to recompute everything. You just can say, we want to find the difference, which we already did, right, with the subtract command. Then we do the embeddings compute for this small subset. Take a look at the result. And now the small subset of the new embeddings needs to be added to the previous subset, which is like old version of the data set, right? And when you combine those together, you kind of like get the new whole data set with embeddings. So you got the idea, right? Like how to incrementally you can like update your data sets without like spending like too much time, too much effort, too much code in order to do this parts. And one more thing is a data set sharing and collaboration across team members. So over the presentation, we did data update with the embeddings. We did some YOLO computations, right? And usually you don't want to waste this result. You want to share the result with the team. And with a database that we use for in the tool, right? That's like an easier way of doing this. So if you can show all the data set, you can see the data table with the data sets as well as the development, right? This is like embedding data set with data updates. Mistral data set with 1, 2, 3, 4, 5. Wow, 9 versions. It's basically like how many times I ran them before. And that's the way kind of like you can collaborate as a team. So this data set can be like imported to some format and shared as a file, or you can put like a centralized database as we do in our SaaS and share this data set. So each team can, or all the team can efficiently collaborate on the data sets. So in the conclusion, metadata, that's how you work, how you make your multimodal data versioning, data management efficient. Pydantic, that's the way how to stay in Python, right? When you need to scale of the SQL, but at the same time, Python, it's your preferred language. And sharing and collaboration across the team, that's the way how your team become efficient, how your team can run heavy compute, share efficiently the result. And again, all the result is like metadata base with the references to this like heavy, massive files that we today working with. So thank you. Please please check out the repository. Project is open source. Yeah, love to see your feedback. Thank you.
All right, thanks to this Kiko, and I think that they have time for a few questions. So, do we have any questions from the audience? I see one right up there.
Yeah. So I'd be curious to hear what aspect of data management do you think is the biggest failing for most MLTs at this point? Because this is very comprehensive, and I'm wondering, like, what you think the biggest single issue is.
Good question. So, like, I work in this like MLOps space for years. I still believe it's broken completely. That's short answer. But in general, it depends on the team. But it's all usually like comes down to the discipline, right? Discipline, organizational. It's like because they're like a no tool that everyone like accepted, right? So far in the industry, there's some popular tools, right? But there are no kind of like a one single standard. So it all comes down to the discipline of the team, right? And a different team have like a different challenges. So it's like today, unfortunately, it's kind of like more like a managerial problem rather than technical, unfortunately. And we're trying to make it automate this and depend less on people and management.
All right. Any other questions? I have a question. So at the end there, you showed that you have multiple versions, right? And that's sitting off in the cloud somewhere. And I'm imagining like you have two people sitting in different offices potentially trying to work maybe off of a single version. How do you handle like both people working off of the same version potentially and kind of merging conflicts from that?
Good question. So in this demo, right, I used open source version. Open source is based on SQLite. It's all local, right? If I want to share these versions with you, I need to import to Parquet file or CSV or whatever, right, and share with you. On the SaaS, it's handled by SaaS. So if you use the same data set, that's fine, but you cannot modify data set. We kind of made this like atomic structure of the data set to protect collisions.
Gotcha. All right. Thank you. Cool. Any last questions? All right. Well, let's thank the speaker again. This was a great talk. Thank you so much.
Thank you.